Hi, everyone. My name is Yifan. I am a research engineer at Stanford University. Specifically, I'm affiliated with the Center for Research for Foundation Models and also the Human-Centered Artificial Intelligence Research Center. And I'm here today to talk about my project called Holistic Evaluation of Language Models, or as we call it for short, HELM, because we love acronyms in academia. So to tell you a bit more about this work, first I want to bring us all back in time to around 1 BC, by which I mean 1 before ChatGPT, basically prehistoric time, and well, specifically 2022. So if you all can recall, this was a time where foundation models were not really that well understood yet. There were a bunch of these coming out. So we were seeing this, like the beginning of this Cambrian explosion of models where the models were getting bigger and bigger, we're getting more and more models, and numbers were going up in general. And at Stanford, we were thinking, hey, we know that these models are very powerful, and eventually they are going to be used for all sorts of things like question answering, information extraction, teaching your kids math. But we're also conscious of the fact that there are some real societal risks, like, for instance, representational bias or stereotypes, and these could harm real users. So we're concerned about this, and we're thinking about how do we actually ground this conversation. And as academics, the answer is benchmarks. So HELM was our attempt of improving our understanding of foundation models by measuring these risks and capabilities using benchmarks. And we wanted to make this information publicly available and hopefully help users, deployers, policymakers make better decisions based on this more transparent information. So Holistic Evaluation of Language Models, or HELM, was a paper we put out around 2022, literally a few weeks before ChatGPT came out. And this was a huge effort with more than 50 collaborators at Stanford. And this was one of the first large-scale evaluations of foundation models, and also one of the most longest running ones, since we've kept this running since 2022. At the time, what we did is we looked at the existing literature for NLP, and we picked 42 benchmarks from the existing literature. And then we picked 30 models from 12 organizations, and we tried as much as possible to run almost every benchmark on almost every model. And this was a very expensive effort. It was 12 billion tokens, 17 million queries. We spent $38,000 for the API inference calls, and we spent about 20,000 GPU hours for the open source models. So we did this because we were noticing that the status quo was basically researchers would release a new data set or you release a new model, and you'd pick a few other models and other data sets, and you'd run a few evaluations, and you'd call it a day. And we were so basically when new data sets and new models come out, usually these numbers don't get updated. So that's it. So if you look at the matrix here, each row is a data set, and each column is a model. So you can see before we did HELM, the number of evaluations available were not that many. So what we wanted to do is really fill out this matrix. So we increase the coverage from 18% to 96%. And all of the results we publish on HELM leaderboard. So these are leaderboards where, again, these are tables of models across benchmarks and all the aggregate numbers. And when we're thinking about this, we also wanted to talk about the principles of evaluation. So in our paper, we sort of expounded these principles of being holistic or comprehensive, meaning you want broad coverage of many aspects, many benchmarks, many scenarios, many metrics. And we cared about transparency as well. So we wanted to make all our prompts and model responses publicly available so it can see exactly what we did. And then we wanted reproducibility. We wanted another researcher to be able to take our code and be able to run the evaluations and make sure that we did the right thing. So to talk about holism or comprehensiveness first, we cared about aspects beyond accuracy. So we realized that accuracy is what most people are going to care about because users and model developers care a lot about, does the model solve my task? Can I use it for something? So they care about a lot about capabilities, but we wanted to also push on other aspects that we thought were important. So we picked a number of aspects like calibration, robustness, fairness, bias, toxicity, and efficiency. We also evaluated on these because we wanted models to improve along these axes. So for transparency, we took all of our raw evaluation logs, all the prompts that we sent to the models, and all the responses that we got back, and we made them available on our online leaderboard as well. And finally, for reproducibility, we took our code and we made it open source on GitHub. So this code has evolved a lot over the various years. It now contains hundreds of built-in models and dataset integrations. And originally we said, hey, you can use this to reproduce our results. But it's gone beyond that. It's now become a more general purpose framework and evaluation toolkit. So researchers and industry users have been using this to run their own evaluations and run their own experiments. And this has enabled many academic papers to be published. Besides the academic impact, the HELM toolkit has also received quite a bit of industry adoption. So teams from various large tech companies have been using the HELM software framework for their own evaluations. And one application that I want to highlight is Apple. When Apple released the Apple Intelligence Foundation models, they use HELM for their official results, which you can find in their model card paper. Okay, so when we're running HELM, so I was mentioning earlier that this was work from 2022. So the problem with keeping a leaderboard running for that long is that the leaderboard datasets get saturated very quickly. And when I mean saturation, you can look at this one example here. So this is a graph for MMLU, which is a academic question answering dataset. And you can see that within a few years, the models are getting basically 90% on this dataset. And when you're at that point, you lose the ability to be able to distinguish between models because all the models are basically achieving near perfect scores on this dataset. So in order to continue, to keep our leaderboards relevant, we have to actually keep refreshing the leaderboards. So this is the latest version that we've come out with, which we call the HELM Capabilities Leaderboard, which we released this year. And this is using new, more challenging data sets, especially data sets that are currently being used by frontier labs to in their model cards for new frontier models. So for instance, instead of using MMLU, which is saturated, we use MMLU Pro, which is a more challenging and recent data set. And we keep this leaderboard updated with new models as they come out. Besides improving that one the leaderboards, should also mention that HELM has grown into a living ecosystem for model evaluation. So we have collaborators from many different organizations who work with us to evaluate various aspects that they care about for foundation models. So as part of the community's work, we now have 19 different leaderboards. We have more than 150 data sets, and we have run evaluations on more than 350 models. So now I want to talk about going back to the present. So what has changed since since we started HELM in 2022? So I want to talk today about whether I think we followed the HELM principles. And when I say we, I don't mean just like HELM, the HELM project team and collaborators. I'm sort of thinking of us as a greater ecosystem as well. Like, are we doing a good job of making today's evaluations comprehensive, transparent, and reproducible? So let me talk about comprehensiveness first. So the original HELM evaluations were text only. And we since expanded. So the general theme I'm going on here is that the various HELM evaluations from 2022 were limited in various ways. So we only could evaluate certain areas. And we've managed to expand those to things that are more relevant today. So one of this is multimodality, where originally our evaluations were just text only, and now we've expanded to multimodal in order to accommodate models that can take audio or images or video as input or generate various modalities as output. So given the importance of these multimodal models, we've covered a few modalities, including text-to-image, where in here we ask whether models are able to generate, say, creative images, like generate images for video game applications, or is it able to demonstrate knowledge by generating, say, an image of George Washington or another famous figure. We've got evaluations for vision language models. So this is asking things like if a model is able to take an image of a location and identify that location, or if it's able to take a math question with a graph and solve that math question. And finally, we also are evaluating audio language models. So these are questions like, is a model able to take an audio conversation and distinguish between different speakers, or is it able to classify emotions in various spoken speech? So another aspect that we've done in this expansion is language, multilinguality. The original evaluations were just English only. We've since expanded to non-English languages. So we have coverage of Chinese, various Southeast Asian languages, and various low-resource African languages. We've also expanded HELMs to other domains. And I'll talk about a bit what this domain means in general. So one example domain is medical, the biomedical domain. So this was a collaborative work with folks from Stanford Healthcare, where our collaborators surveyed physicians and professionals working in the biomedical space, so including people like administrative professionals. And it asked them, what tasks do you do in your day-to-day life? What tasks do you think can be performed by foundation models in the future? And we built this taxonomy of various tasks that we cared about. And many of these tasks are not just things like biomedical scientific questions or medical questions. Some of these tasks were things like, oh, can you do scheduling care for patients? Can you provide patients with care follow-up instructions? Can you do administrative paperwork, for instance? So we took these tasks and we found either pre-existing data sets for these tasks, or we found in some cases we built new data sets using data that was available to Stanford Healthcare. And we ran this evaluation, and we think that this gives a better reflection of whether LLMs are good at a task that a hospital would do. We think this is a better evaluation than just giving them a doctor's exam, which doesn't really cover the whole breadth of available tasks. So another thing that we worked on was safety. In the context of this work is that we realized last year that even though the research community had produced a lot of very useful safety data sets, we realized that a lot of frontier labs are still releasing frontier models and not actually publishing results on safety evaluations or even running these safety evaluations. So we thought, hey, maybe we should just solve these problems ourselves and run standardized safety evaluations using existing peer-reviewed data sets across all the models. So we have this baseline of safety information. So we did that. We picked 5 data sets that cover aspects such as discrimination, sexual content, violence, harassment, and so forth. And we ran this across frontier models. And this is still a leaderboard that we are maintaining today. And final domain I want to talk about is the domain of emerging government regulations. So government regulations are a rapidly evolving field, obviously. And we thought, hey, can we measure whether frontier models today are compliant with what policymakers are thinking of in terms of regulations? So we looked at 3 different geographies, specifically the US, the EU, and China. And we looked at the regulations that were emerging in each of these geographies, each of these jurisdictions. And we built this taxonomy of various categories that these regulations cover. And then we built a novel data set that covered that basically checked if models were able to refuse dangerous requests that were not compliant with some of these government regulations. So I've talked a bit about the work that we've done in HELM. Certainly the whole evaluation community has come out with a lot of different data sets, a lot of different directions in the last few years. So what's missing? I do think that there are several things that we don't have good coverage on. So one of it is evaluations for complex behaviors, such as sycophancy. And these are behaviors that emerge typically over long interactions with users. So they're not something that are going to emerge like with a single turn with a static data set, which is kind of the more traditional way of doing benchmarking. So I think we need better approaches to think about these benchmarking these behaviors. Another thing that's missing is evaluations for professional tasks in industry, especially when I'm talking to like our collaborators from industry. They frequently say, hey, we need evaluations to figure out if models are going to be valuable for like specific business use cases. And this is challenging for various reasons. Companies are not, so data is a big challenge. Companies are not always able to release data, either because of trade secrets or user privacy or data protection policy or so forth. So it's a lot harder to find data to build these things. And also, a lot of professional tasks require professional expert judges, and the time is very expensive. So that's also challenging. I did highlight GDP-val by OpenAI as an example of something, a benchmark in this direction, but I think there's really not very good benchmarks here. And third one is evaluations grounded in non-Western cultures and languages. A lot of these data sets, there's a lot of data sets that are basically like English language or Western country centric. And there's not as many good data sets that are specific to global cultures. So I highlighted Korean BBQ here, KoBBQ, which is a biased data set for the Korean, grounded in Korean culture. And this data set is very different from, say, what a biased data set grounded in US culture would look like. And finally, I think we need more evaluations for emerging user harms that we're starting to become more apparent. So the one that I brought up here is LLM delusions, where interacting with LLM seems to make delusional disorder symptoms worse for some users. And I feel like these are pretty important things that we should be thinking about, and that existing safety data sets do not have good coverage of yet. Okay. So the second pillar of HELM, transparency. So we've made all raw evaluation logs available on our website, and these turn out to be very useful for diagnosing issues in models and data sets. So I want to talk through a few examples of this. When we did the MedHelm project this year, the medical evaluation project, we found that Gemini was doing quite a bit worse than we were expecting. And we looked at the raw logs, and then we realized that Gemini was refusing to answer some of these requests because its safety tuning had said, hey, you should not be answering medical questions from users because this could be potentially dangerous for users. So it was just refusing this request, but we were scoring this as incorrect, even though it might know the medical knowledge. So it's not really, this benchmark wasn't really testing what it was supposed to test, which is medical capabilities. Another example of like surprises we found was this example from OmniMath here, where we found that, hey, there's this one instance. So OmniMath is a mathematical benchmark, and we can find instances where the question just contains the answer. So the model just is able to answer, and you're not really testing anything. Here's an example for something that is not HELM. This is from the Holistic Agent Leaderboard, which is a agent benchmark. And on this one instance here, there's an example where the model just cheats, where it just Googles up the answer in archive and returns it without doing what it was actually supposed to do. So although raw evaluation logs are useful, I don't think there are many, I couldn't find many projects that actually make these available. So there's HELM, there's the Holistic Agent Leaderboard. I should say that MetaLlama 3 is great at publishing. They've published all their evaluation logs for the Llama 3 series. And another project I'm aware of that does this is Dove as well. But unfortunately, it's quite rare, which I think is a pity because there could be some useful research to be done if you had this kind of resources available. The last pillar I want to talk about is reproducibility. And this is probably the most problematic of the three. So we realized this when we tried to do a third-party reproduction of MMLU in HELM. So MMLU is a multiple choice academic question answering benchmark. And we found that we got many very different scores from what the model publishers had said. So in one case, we got a score that was 5 percentage points lower than what the model claimed the score was. And I'm not really saying this is cheating necessarily, but this is, very problematic. And we weren't the only people to notice this. Hugging Face also, they also noticed this because they ran their own evaluations. So they found that if you use the LM evaluation harness, you use HELM, and you use the original MMLU papers implementation, they found that you get different results. And in fact, you get different model rankings depending on which implementation you use. So this means like reproducibility is very hard, and models are sensitive to small changes in evaluation setup. So to give one example, going back to the project I mentioned earlier, DOVE, the DOVE project tried running evaluations using a large number of prompt variations. And each dot on this graph is a single run using a certain style of prompt. And you can see here, like there's a huge range of results you can get depending which prompt variation we use. We also saw this ourselves when on one of our HELM projects. So we have a table reasoning benchmark that we call TOR, T-O-R-R. And this is a table understanding benchmark where the model is supposed to answer reasoning questions over a table of data. And we found that if you change the format that the table is serialized using, so like if you use CSV or JSON or Markdown or something else, we found that this causes the result to vary a lot. And it's not consistent, there's no consistent preference. So for each model, there's not a consistently preferred format, and for each benchmark, there's not a consistently preferred format. In HELM, another issue we run into is just instructions, which seems like something really basic. So say you're telling a model to answer a multiple choice question. You might say something like, answer with only a single letter. But maybe we included like demonstration examples as part of in-context learning, and your model just tries to answer all the questions, including the example questions. So you might have to say, answer the last question with only a single letter. And the model might say, okay, I'm going to include extra punctuation like A dot, B dot. So you might have to say, no, don't include an extra punctuation. So this is all very annoying because this means that we have to think about the instructions, and different instructions might work on different models. And even worse, if you look at the, again, going back to the work by Hugging Face earlier, where they were analyzing different implementations, they noted that different implementations use different instructions, and sometimes this changes the model ordering. So you might think, okay, but we can solve this, right? We can solve this using prompt engineering, or even better, prompt optimization. Let's just use a program to come up with the best prompt for each model, so that we know that we're getting the best performance of each model. So in another work, we ran a prompt optimizer, specifically MePro from DSPy, on various model prompts. And we found that, okay, this does lead to an increase in performance, sure, but it can actually flip your rankings. So if you're running your benchmark on the same prompt on all models, you get different rankings than if you specifically optimize the prompt for each model, because different models benefit from the optimization by different amounts. Another problem that I run into is that very frequently model developers disclose insufficient information for reproducing the evaluation. So there's one example from the Gemini model card. This is Gemini 1. they solved MMLU basically. They were like, we got 90% on MMLU, which is amazing. But they used this chain of thought at 32 decoding method that was not specified, like it was specified incompletely when there's this hyperparameter threshold that's not like stated anywhere. So even if I wanted to, I can't reproduce this evaluation that I run. And this is still a problem today. Like this was the most recent model cut from Gemini 2.5, and they have this benchmark here that's MRCR v2, which MRCR stands for multi-reference co-reference resolution, which is a long context benchmark. But anyway, this dataset is not publicly available, so they just say, I guess if you want to run it, you just have to trust that we ran it and you can't do it yourself. So it would be kind of nice if we had a universal benchmarking standard and just solve all these problems. But I think standardization is hard. So this is my favorite XKCD comic. If you try to introduce a new standard, you just end up competing with all the pre-existing standards. So I know there are other researchers that have proposed this, like, let's just do a new standard. I personally think that it's a better, like the approach I recommend is just use the open source implementation. Like just use either the original implementation or HELM or one of the very many HELM alternatives such as LM Evaluation Harness, like Evalchemy, Unitext, Inspect AI. And these are all great open source projects. So I would recommend using one of these and then publish enough information so that we know what you did. And even with all of this, there's like much more problems with reproducibility that I haven't gotten into, like LLMs as judge, introducing more noise. We have more upcoming work on that. Okay, so conclude, I think the principles of HELM are still important today. We still need to be comprehensive, transparent, and reproducible. And also, I think that there's still many interesting problems in basic benchmarking to be solved. The rest of this day is going to be a lot of frontier evaluations and new, novel, creative evaluation methods. But I think that even with traditional benchmarking, there's still a lot of work to be done. I'd like to acknowledge my many, many, many collaborators, many of whom did not fit in the slide, unfortunately. And if you'd like to follow me, here are some links. Thank you very much. I think we have time for a few questions. One question.
Hi. So you mentioned earlier that you have many leaderboards. I was wondering, like, if you have or you're planning to work on a leaderboard for LLM evaluation early in the training, because the current scientific benchmarks, like MMLU Pro, they don't give any signals for LLMs early in the training, and for the community, it would be nice to be able to try stuff very quickly without like training LLMs for a long time and waste a lot of money. So yeah.
So the question was, we don't have that for HELM specifically, but there's a different project at CRFM that does that. So we have a project called Marin, which is a LLM pre-training project that's totally open source. And I think that's actually in a conference presentation on Thursday, I believe. But anyway, like we believe the easiest way to do evaluations in the middle of pre-training is to do just like MMLU and then just do perplexity evaluations and just do decoding log prop evaluations. And that gives you like a very smooth, the advantage of that is if you do that, you get a smooth graph of your training tokens to your evaluation metric. Whereas if you use these approaches like prompting and just taking the response, you end up with a very jagged graph that like doesn't, you basically get a graph that looks like this, that's kind of spiky. So that doesn't work very well. So that's like what we recommend to do for pre-training.